Bismillah Rahman Rahim. So let us start our module 2. So in this module, we will be studying about the basics of ETABS and SAFE, and we will not be going into very deep into the ETAB and SAFE for the very basics, but we will go through some of the useful commands and interface of the ETABS and SAFE, and then we will be dealing with the use of the common commands, which are very basic commands which we'll be using in this course throughout. And then we will be talking about the common modeling mistakes which is normally found in the designer's model, in the student's model. So for the interface of the ETABS and SAFE, and then for the use of the common commands, we will go through. सही रटिक जागा माइक पंच सवाल दर्जी. So Bismillah Rahman Rahim. So let us start our module 2, and in this module we will be studying the basics of the ETABS and SAFE, and it includes the interface of the ETABS and SAFE and the use of the common commands, and then we will be dealing with the common mistakes done in the modeling. So for the interface of the ETABS and SAFE, we'll go through the different commands in the software and interface of the softwares, and we will be not be dealing with the very basics of the ETABS. We will normally go through the basics commands which we'll be using throughout this course. So let us go to the ETAB. You can use, I'm using for this course this SAFE version 16. You can use SAFE version 12, you can use SAFE version 16, 20, 21, 22, and you can also use the ETABS version 2016, you can use 2018, 2019, whatever the software is compatible with your laptop. So this is the interface of the ETAB when you open your ETAB. So all the commands are non-clickable, and if you check or click on this file, this one is only clickable, and you click on the new model. So this window will appear, and it will say that you are using the different settings previously. So it has saved the settings, so you can use that setting, or you can also define your OSMI for example the display units, it is US, and the section database for the steels design, and for the steel design this is the different codes, AISC, LRFD, and all the Indian codes, Italian codes, whatever you are compatible with. And then there is a concrete design code. For example, you are using SCI 318.14.11.08, you are using the British standards, you are using the Euro code, your Hong Kong code, Indian code, and you have to select the desired code as well. So we will be selecting the SCI 318.14, and we will click OK. So another window will appear, and it says the new model quick templates, and in here you can model your structure very quickly. How we can do that? So the first one is the grid dimensions, and it will be showing you in plane that what are the number of grid lines in X direction, Y direction, the spacing in X and Y direction, right? And then there is a grid labeling. You want to start it with the A, B, C, or some specific other labeling as well. And you can also specify your own grid spacing by clicking on the custom grid spacing, and you click on the edit grid data, and you can edit the different spacing and the grid IDs for your structure. For example, you can add, this, you can change the spacing like this. So this is taking the display grid data as a coordinates. For example, you're starting from 0, then it will go to the 0 from 24, then from 0 to 34, then from 0 to 72, then from 0 to 34. This is the coordinates. Similarly for the Y direction. But if you want to give the spacing, for example, your grid is separated by uniformly spacing, for example 20 feet, you can click on this display grid data as spacing, and you can write it down 20 20 20. So you can see the changes appeared in the up, right, and corner. If you change the spacing, the grid will change, right? So this is how you can give your grid dimensions as a coordinates, sorry, as always as a spacing. You can insert the reference points in different stories level. For example, this is the x coordinates in y, this is the y coordinates, and it's visible or not. And you can also give the reference planes as well in the z direction. For example, this is the z coordinates in the story level. This is for the planes and this is for the story. We will talk about this in our model. So click OK. If you do not use this, again you click on this. And so this was a whole story about the grid dimensions. The next one is about the story dimensions, where you will specify your story data, that how many story you are designing. For example, we are designing a 10 story, and what is the typical height. For example, typical height for the above story and the below story is 11. And you can also edit these stories by clicking on the custom story data, and you can edit the story data in here. You can insert, for example, if you right click on it, add story, so you can insert the story as well. For example, this is 11. I want to insert a story about 3, and take the replicate, for example, copy of story 6, and click OK. So story will appear. For example, this story has been inserted in the story. I click OK, so it will insert a story in that, right? The next one is the structural objects. For example, if you want to create a blank model, and if you want to create only a grid only, so it will take the data from grid dimensions, story dimensions, and it will only create grid story, right? And the next one is for the steel discs and the staggered trusses, the flat slab with perimeter beams. We have discussed this in our module 1. This is the waffle slab. If I click on the waffle slab, this is actually a two-way choice system which I have explained earlier. If you want to insert a drop panel in it, you can click on this. So in here in waffle slab, you can insert the different parameters and the dimensions in here. You can insert the structure system properties. For example, what is the property of column, what is the waffle slab property, what is the drop panel property, and you can define quickly in here by clicking on 3 dots, and it will appear the new window specifying, asking for the define the frame properties for your structure. You can define a new property and you can select any uh, sizes, and then you click OK, and you can, so there is an example. So this is the way you can construct your model very quickly. So there is an error in here. Let me delete this. The structure, the slab system we have discussed in our last lecture. You can see all of these in here. For example, if I click on the flat slab, you can see the different properties, and you can select the column properties, slab, and drop panels. And if you want to include the drop panels or not, you click on unclick on it, right? And then this is the post tensioning. You want to restrain the bottom as a pin or as a fix, you can select that. You can apply the load, that is the additional load, which is the superimposed dead load, for example 100 psf, and the live load is for example 40. And if you want to insert the diaphragm rigidity, whether it's rigid or semi-rigid, actually the difference between rigid and semi-rigid, that for example you are designing your structure as a concrete, you have to apply as a rigid, because it will transfer the forces from coming from the seismic loading, and then you transfer into the beams, and the beams will transfer into the columns. But if you are designing a steel deck, for example, or a wood panels, or a precast concrete slabs, then you have to apply the semi-rigids. And then you click OK, and let me click on OK. You can see that the template has been, because we have selected 4 stories, so 4 stories has been modeled very quickly, right? So this is the overall interface. Now every command is clickable, and you can go, there is a file where you can open the file you have saved earlier, and you can close the program. You can save, then save as. You can import different files from the different softwares into the ETAB. For example, if you have modeled your structure in ETAB version 9 or version 16, and if you want to insert that in the lower version or the higher version, you can use this command ETAB E2K file, text file, and you can insert it from the higher version into lower version. Because if you model a structure in your the higher version, for example ETAB version 20, you cannot open that file in ETAB version 16. So that's why you have to use this command by importing the E2K file. First we have to export E2K file from the high version, and then you have to import this E2K file in the lower version. And you can insert the Revit structure file, CAD file, architecture plan. We will be using this command today, inshallah. And then the architecture grids, the XF files for the floor plans, and these are also these 4 5 are the CAD files. The CSS file, this is from the conversion of the from the SAFE 2000 into the ETAB. This is also ISF file is from the SAFE to into the ETAB, and this is the Stud Pro, and this is for the other softwares. Similarly, you can also export to different softwares. This is for the other version of the ETABs, and this is for the ETAB into the Excel, Axis, XMM, and partial ETAB files. And you can export the file into the SAFE from here, story as a SAFE. You can export your model into the Revit, into the CAD, into the SAFE 2000, into 3D printing as well. And you can also export the file into the steel detailing. Right, we will be talking about this into your course time to time, but we will be focusing on the very basics. You can study it out in the manuals given in the ETABs or the SAFE. We will be talking about this. I will show you where you can find the different manuals to start very from the beginning, and you can go to the expert level. You can create your report in here for your projects, summary report or detailed report. You can also capture photos, or you can make videos when you after the analysis. This is not clickable because it will be after you complete your analysis. You can insert the project information. For example, what is the client name, for example ABC, what is the project name 123, and what is the engineer name, for example finally, and who is checking the your software model and your drawings, and you can insert all of these data in your project information. So this information will appear when you export or create your project report. The next one is the edit. We will be using this command time to time, but we will be talking very basics. So this replicate command is very common in the use. For example, let me delete this story 4, and let me go to the on the plane. For example, this is the plane of story 3. Let me select story 3, and let me go to the edit replicate, and you can replicate as a linear, radial, mirror, story. So story will be using very frequently in our modeling as well, and when you go to the field in your consultancy or you are doing research projects, you can use this command very often. So you have to select, we have selected a story from story 3 structure elements, and we will replicate it in the story 3. Let me go to the 3D, and if I haven't clicked only on the apply button, if I move a cursor on the apply, it will show you a projection that the story will be like this. So I will say okay, click on apply. So the whole story has been replicated from the story 3 to story 4. You can replicate one single element, one single plan, one single slab into the different stories. You can use the linear. For example, I want to create a replicate of the whole building. I will go to the, this is another command which is very commonly used at the right hand corner. It is says one story, and for example, and if you click on the all stories command or similar stories, for example all stories, and then you select all the, you can check on the left hand corner that the 208 commands has been joints has been selected. And if I go to, for example, let me, we are using plain linear, let's go to the linear replicate, and I want to select only 2 points, so I will, for example, not, we will use 2 point again. Then increment data, for example, this is 24, 24, 24, I will use it as a 200. 200 in X, you can see that the projection has been shown that this system will appear in here. So if I click on apply, you can see the two model has been replicated. And similarly for the radial and for the mirror as well, you can use this command. The next is about the edit frame, edit shell commands, where you can join or divide different frames and shells. You will be using this command as well time to time. For example, if I want to divide this, this is a complete whole panel. If I want to divide this with the frames that has been assigned to the or attached to the slab or the grid lines, I will select all of these. I will go to the edit shell, divide shell, and I will click on the edit triangular into intersection with visible grids with the joints intersection of the selected frames. Click on apply. So this has been divided into small panels, right? If I go to the edit, I want to join these, so go to the edit shell, merge shell, it's not working. So this will merge your shell. So anyway, so this can work because there is a abnormal error appeared earlier. Similarly, you can also click on the different, for example, expand and shrink chambers, or you can also give the chamfer in the slab corners as well. So these are the different commands which we'll be using commonly. So the next important thing is the define, where we will define our material properties, section properties, and then we will define our diaphragms, we'll define our piers, spandrels, we'll define our mass source, load patterns, and then shell load sets if you want to define that as well. And you can define the load casing and load combinations, right? So if I go to click on the section properties, click on the frame section, so this window will appear. You can import the different properties available in the database of the ETABS, or you can define your own property, right? If I click on the define new property, if I click on the concrete, so here you will define the dimension for the, for example, I want to define 24 cross 24 column, and then this is the property which is the FC prime will be used in the columns, and then what is the different nodes from the add something in here, so you can write it down. And this is the shape if you want to change the shape, and this is the properties modifier we'll be using in our coming lectures. And then this is the reinforcement where you will define whether it is a beam or column. If it is a beam, click on this. If it is a column, then click on this beam option. And here this is the rebar material to be used, and this is the cover, and this is the reinforcement area overrides for the ductile beam. This is for the existing beams. If you want to check existing beam reinforcement, you can use this command. The next is the important thing is if you go to the help menu, and if you click on the documentations, you can see there's a variety of documents available. And if I click on the tutorials, and if I click on the introductory tutorial, so it will open a file which says the computer and structures instructions. and it is introduction part 1 and 2, and you can see it has defined all the commands and all the properties of the commands that available in the ETAB, right? Add frame, how you can add frame objects. It has explained different steps. It has defined different commands, right? How you can add story data, how you can draw columns objects, what are the different commands to be used. All of these are included in this introductory tutorials. The next is the manuals. If you want to take help from the ETABs, it says welcome to the ETAB, and this is the user guide, and this is the analysis preferences manual. This is the lateral load manuals, and this is the software verification example. If I click on this, so there are different examples has been solved for you. For example, there is a slab design for a simply supported rectangular plates, or the, for example, the plane frame with beams, span loads, and there is a manual calculations, and there is a calculation of the SAP 2000 in ETABS. So you can also check it out these examples, and you can create your doubts if you have any doubts that whether the manual calculation is the ETAB is doing the calculations correct or not. So you can verify the examples in here. The next is the lateral load manuals. If I click on this, so there is another document where you can check it out. The lateral load manual. It has defined the different parameters and the methods that has been used in the ETAB taken from the different codes. For example, it will explain the UBC 94 seismic loads, what are different options available in the ETABs, and you can check it out the different codes available in this lateral load manuals. You can check it out the other as well. The next is the, for example, the concrete frame design. You can check it out. For example, the ACI 31814. If I double click on it, so there is a documents for the concrete design manual. You can check it out. What are the different parameters has been used? How you can design the structure as per the ACI 31814 in the ETABs. Let me go to the design of the columns. So it will explain the program can be used to check the column capacity or design the columns, if the geometry of the reinforcement bar configuration, and all of these you can check it out. It is explained the interaction diagram, how the program works, and how the program calculate the capacity of each column by calculating the axial forces and the moment in the minor direction and the major direction, and it will insert that point in the envelope curve of the interaction diagram, and it will show you whether the column is capable of taking that load or not. It will show you the or stress command uh, result in the design of the columns. The next is another technical notes. You can check it out for the ISF import and export, and then there is also verification for the, for example, there is also introductory documentation. You can check it out. So these are the different documentation available in the ETAB. These documentation also applicable for the SAFE as well, because these are available in the SAFE also. There's also a manual of the shear wall. If you want to design a shear wall with the ACI 31814, you can check it out the different parameters used in the ETAB and how the ETAB calculate different factors, and how the ETAB design your shear wall using the ACI 31814, right? So these are the interaction diagram for the pair of the shear wall, and how the structure is said to be passed or failed based on these interaction diagrams. So there is also another different commands available in the ETABS and SAFE. So we will be using those commands in time to time in our modeling and our design infrastructure. So there is on the left side there is a quick command icons. For example, this is the draw beam slash column brace in plane. If I click on this, you can draw your beam in plane. And this is for the quick draw. If you have grid lines, so this command can only be used. And this is for the columns. you can draw your column in plan. This for the secondary beams to be drawn between the primary beams. This is for the bracing. This command is used for the draw floor or wall in plane elevation in 3D, and this is for the rectangular section. For example, if I click on this, you can draw only rectangulars, and in this you can draw polygons. And this command is only for the grid lines. You can only use this command when you have grid lines in your model. This is for the shear walls or retaining walls. You can draw it as it is you want. But this command is for when you are want to draw the walls on the grid lines. This is for the openings, to draw wall openings in the plane elevation in the 3Ds. This is for the link, which is not part of this course. This is the wall stick, which is very important. If I click on this, you can define your shear walls and lift walls very quickly in here. For example, if I click on this, so let me keep this as default. If I click OK, so you can insert, for example, this lift wall has been drawn very. You can draw your lift walls and shear walls manually, but this is very useful and it will save. For example, if we have here four lift walls adjacent to each other, you can draw it very quickly with only one command. Right? If I go to the 3D, so it has been drawn in all four stories with the spindle beams and all of these openings. The next is the all previous. For example, if you want to select all the atoms, you can click on the all, and if you want to delete it or hide it, you can. For example, if I right click anywhere and there is a command hide the selected object, and click on this, it will hide all the selected objects. And if you right click and show all the objects, you click, so all the objects will be appeared. And if you select this, and if you want to clear this selection, click on the clear. And if you want to select the previous structural objects you have selected, click on the previous, so it will select the previous deselected objects. The next is the add modifier grids. So this is the same window appeared, we have discussed it earlier, that you can modify your grid system. In here you can add grid system, you can import or export or copy the existing grid system, you can change the story data, you can add the quick story. For example, if you want to add 3 stories quickly, you have to click 3 times, and if I go to modify, so 3 stories will be appeared. I click OK, so 3 stories has been added, but it has not been replicated. That's why only grid lines has been replicated. If I want to add stories and take the copy of the story 2, I will go to right click on this add story, add the keep existing story heights. I will add the story height, I will add number of stories, for example 5. Insert the story about the 7 and take copy of story 2. Click OK. It will take some time. The story has been added. If I click OK, now you can see all the stories has been added very quickly. Right? So these are the different commands. This is for the new model, the existing model to be opened. This is for the save. This is for the undo. This is for the redo, and this is for the lock unlock. This is for the run the analysis. This is for the zoom. All of 5 commands. This is for the pan. This is 3D plane. Want to click on the plane, and this is for the concrete design. If I click on this, so there's a view revise preferences, so you can select the design code and you can change the different parameters if you desire to change them. We will be using these commands time to time. Let us go to the safe. So the same window will appear if I click on the new model. So there is a bit difference in the ETABS and the SAFE. there will be, because the SAFE is used to design the beams, slabs, and foundation only. You cannot design the frame, the columns, and shear walls in the SAFE. So there is a flat slab with perimeter beams, two-way slab. This is mat. This is a rough. There's only waffle slab, rift slab, single footing, and combined footing. So this is the same thing we have discussed in the ETAB. If we go to the mat foundation, and we will keep this as default, and we click on OK. So this is the mat foundation, right? So let me run this very quickly. For example, go to the documentation. If I give it as a name, so there are the different commands that very useful. For example, if you want to check the soil pressure or the punching shear, for example, I go to the display and show the punching shear design. It will show you the punching ratio. This is the demand to capacity ratio. If it is less than 1, then your structure is safe, and if it is greater than 1, this ratio, then you have to increase the thickness of the raft or increase the FCPAM, concrete compressive strength. Or you have to design the integral beam for the raft. You can check it out, the slab design, show slab design, and it will show you the you can design it with a strip based, you can design with finite element based. This is the reinforcement, top, bottom, and direction 1 2. If I click on this, so you can see that the reinforcement has been shown. Click on minimum, so this much reinforcement is required for the design of the raft. We will be talking about this time to time in our design of the raft. So 0.518 inch square per foot reinforcement is required. So this is the another command, typically uniform reinforcement. So I want to check whether if I give a reinforcement, for example, if I give number 6 bar at the rate 6 inch and its center, I click on apply whether the more reinforcement is required or not. You can see that the slab finite element design, top rebar intensity in Wilping inch square per foot, direction 1, additional to number 5 at the rate 12. This is the top. If I click on the bottom, so you can see the contours has been disappeared. It means that if you provide number 6 at the rate 6 inch center, no other reinforcement is required. For example, let me check it. For example, if I want number 4 at the rate 6, so you can see reinforcement is required addition to number 4 at the rate 6 inch center. Similarly for the top, let me take it as a number 6, and we go to, you can see no more reinforcement is required. Addition to the number 6 at the rate 6 inch centimeters. So this is the way how you can check the punching and the reinforcement in the shaft. And the different commands are same for the SAFE, which we have discussed in the ETABS: export and import, edit, define, draw. These are the same as compared to the ETABS. So this was the whole story about the interface and the different commands to be used in the ETABS and SAFE. The next is the common mistakes which normally students do. The first one is the joint restraint. When you select the joint at the base to assign joint restraint while all story command is selected, it will assign restraint to all stories, and the designer will not know if the restraints are off from the display option. Example, this is the model in which if you select this base and we assign restraint, so it will assign restraint to all the stories, and if the restraints are off, so you can see in the right model the restraints are off, but it is not visible. It is not visible, but there is restraint. If you right click on that corner, this command will appear and will show you the restraint has been X, Y, Z, and RX or YZ. For example, let us go to this model. Let me delete all of these. I have selected the all story command, you can see in here, and if I go to the base and if I want to assign fixed support, so if I select the joint, it will select all the joint on the all the stories, but you are seeing it in the plane, so you mistakenly assign the joints into this is the fix support, this is the hinge, this is the roller, and there is the free end. So if I click on the fix, click on apply, so it will assign the joints into the all stories. If I right click on this, this is the option, the display set option. And if I turn off this joint restraint springs, click on apply all windows, click on apply. So you can see that the restraint has been off, but there is restraint. How we can verify that? If I right click on this joint, you can see that the assignment tab, the restraint has been assigned. So the design will be found in this case. Right, so this is very important to keep in mind, this common mistake. The next one is the overlapping of beams and slabs. So the structure should be modeled very carefully as it will represent your actual building. So there should be no overlapping of the beams and slab. Otherwise, sometimes the software will not run, it will show you error. And check the model before you run the analysis and design. How we can check that? You go to the analyze, click on the check model, select all, and click OK. So if there is an error, if there is an overlapping of, and there is any other error, so it will show you error in here. But when there is no error, so it will show you the model has been checked, no warning messages were generated. For example, let me overlap a beam or a beam. I draw a beam, or there is no beam, so let us draw another beam. You can see there are two beams and these two are overlapping each other. Let us check the model again. You can see it has been highlighted. Now it will show you the warning error that these two beams are overlapping at each story, because we are using all story command, so it will show you the same beams in all the stories, right? So these two beams are overlapping, so you have to delete that beam, and again you have to analyze the model whether the error has been eliminated or not. You can see the error has been eliminated. So this is the way you can check your model before you run the analysis. So this is the example. The model has been checked and the two beams are overlapping, so you have to delete that beam and you have to check that model again. The next one is the self-weight multiplier, that it should be one for the dead load, not for other load patterns, as it will calculate the weight of the building based on the member section. So in the define load patterns, so there is an option self-weight multiplier. This should be one only for the dead load, because it will calculate the weight of the structure based on the section properties defined in the model. If you, for example, if you select live, for example, sorry, dead SDL, and if you write 1, so it will also calculate the weight of the structure based on the SDL applied on the different structural members. So it will give you overweight of the structure. It will calculate overweight over base shear. For example, if the actual base shear is 100, it will calculate 1500. So the member size will increase, reinforcement will increase, and your structure will be uneconomical. The next one is joint connectivity, which is very common. And if the joints are not connected properly, it will not give you realistic results, and the design will be effective. So in the figure, the connection looks like perfect, but it is not. For example, this is the plane, and if you can see, there is no such an error I can see with my eye on the plane. But when you design or run the analysis, you must check it with in the 3D, in the deflection. For example, this is the video of this model. You can see in the plane, the joint looks like perfect, but in 3D, in the animation, it is not connected properly. So when the joints are not connected properly, so there will be very different issues created in your model. So the software will design this beam as a cantilever. There will be a lot of deflection in your system, and the system will not be stable. Right. So joint connectivity is very important. So these were the some common mistakes. We have to be careful about designing your structure. And these are the references. And if you have any questions, you can ask.